All right, here we go. Question number 10 from our 1316 homework number 2 in MyLab Math. Here they want us to graph a secant function showing at least 2 cycles and then use the graph to determine the domain and the range. All right, so let's get started by copying down the problem. Y equals 3 secant. We have a secant of 1/6 x. And so what we're going to do first in order to graph a secant or cosecant is we're going to find the trig function that it's related to. Secant is related to cosine. Those are reciprocal functions. And then we're going to graph this following the 6-step method of graphing a cosine. And at step number 6, we're going to switch back and address the fact that it's really secant. Okay? So here we go. Step number 1, graphing, we're now doing a cosine, is to locate the starting point. And the starting point is determined by whether you have sine or cosine, which we have cosine. And so that means that we're going to start on the y-axis at A. Whatever A is, that's where we're going to start on the y-axis. And so we're going to be starting at 3. Here A is 3. All right, step number 2, phase shift. Since C is 0, we're not going to have a phase shift. And the way I know C is 0, in order for there to be a value for C, it would have to be a number added or subtracted to the angle, to the x value of the angle. And there is no constant in the angle there. So our value for C is understood to be 0, which means we have no phase shift. But we do have to consider whether there is one or not. Step number 3 is the wavelength. And the wavelength is the period. Now the period formula for sine and cosine is 2 pi over b, where b is the coefficient of x. So this is going to be 2 pi over 1/6. And we're going to have to do a little KCF, a little keep change flip, which means we're going to have 2 pi times 6 over 1 multiplied by the reciprocal gives me 12 pi. And so we're going to have a wavelength, we're going to have a period of 12 pi. Step number 4, we need 4 spaces. The period has to be cut up into 4 equal spaces because the hash marks in that instance will be where the points go. Step number 5, we will lay out our points, lay out your points. And then step number 6 normally would be connect the dots if we had a cosine for real, but step number 6 is going to be different since it's really a secant. All right, so now let's get a coordinate system. Let's see here, coordinate system. My bad, my pen's acting up. And we're going to go through the 6 steps and create the graph, okay? Step number 1, starting point. Cosine starts at A. A was 3. And so our first point is going to be up here at 3. And there's no phase shift, so that point is going to stay there. The wavelength is 12 pi. So I'm going to come over here and say, yeah, that looks about like 12 pi. You get to decide how far over to go. And the reason I'm coming over and making that 12 pi is because if you notice, I started at 0. That starting point is lined up with 0 on the x-axis. And from 0 to 12 pi would be a distance of 12 pi. And you always finish where you start. So if I start up at 3, I'm going to finish up at 3. So that's my wavelength from start to finish. Next, I need 4 spaces. So I'm going to cut that up into 4 equal spaces. And then I can lay out my points. So notice my first point is maxed out at 3. So I'm going to come down to the x-axis. And then to -3. And then that bottoms out. So now I have to head back up to +3, okay? And then normally what we would do at step number 6, if this was really a cosine, is we would play connect the dots and we would make a wave. But this is not cosine. This is secant. So what we're going to do is we're going to say, okay, now for step number 6, really the x-intercepts become asymptotes. So everywhere there's an x-intercept, I'm going to make that an asymptote, and the other points become my humps and bumps. That's the best way I know to explain it. Okay, this is going to be a up hump. This is going to be a down hump, and then another up hump. Okay, now let's see. If I continue to mark this off, this would be another asymptote, and then I would need another 1, 2, 3, and another 1 over here. So the asymptotes are ever 2 hash marks. So there's an asymptote, and there's an asymptote, and there's an asymptote, and then we're going to continue to play connect the dots. So this goes here, and this goes here, and this is an up, so we're going to go down, down, and I've got another down hump, and then this could continue infinitely far in both directions. Now we need to figure out where those asymptotes are. Really need to figure out where those asymptotes are. So if this is 12 pi, and that's at 1, 2, 3, 4 marks over from the origin, then half of that would be 6 pi, half of that would be 3 pi. So this first asymptote is at 3 pi. Okay, count with me. 3 pi, 6 pi, 9 pi, 12 pi. We're counting by 3 pi's. So 12, 13, 14, this would be at 15 pi. Another one would be 18 pi. Next would be 21 pi. And then if this is 3 pi, then going backwards, this would be -3 pi. So we can see where those asymptotes are. -3 pi, 3 pi, 9 pi, 15 pi, 21 pi. We can see now where the asymptotes are. And we can also see the gap in the middle where there is no graph. Can you see right in this area here? From -3 to 3, there's like a void where there is no graph. So let's see if we can pick the correct answer from our hand-drawn graph here. Our first hump is going up centered on the y-axis. So A is out. A cannot be a valid solution. Neither can B. It does not have the up hump centered on the y-axis. Well, neither does C. So it has to be D. D is the only one that has an up hump centered on the y-axis. And does the scale look about right? Okay, so I've got part of a hump, and then I've got a down hump, and then another part. By the time I get to 12 pi, I've covered a full and 2 halves. So let's look at that. There's a half, there's another half, and a full. This is looking good here for D. And I could go check Desmos if I wanted to, but I feel pretty confident. So I'm going to go ahead and check that answer. And then we need to figure out the domain. Now, the domain are the values that x can be. And so everywhere we have a vertical asymptote, that is a value that x can't be. So the domain is going to be the set of all x such that x cannot be anywhere the asymptote is. Now our first asymptote is at 3 pi, and then the next one is at 9 pi. So let's see, in order for that to work, we're going to say x cannot be 3 pi k, and then we have to determine k. Now, if k is 1 times 3 pi is 3 pi, gets me the first asymptote. And then what if k is 2? 3 times 2 would give me 6 pi, but 6 pi is not an asymptote, okay? I've got to actually jump to 9, so k would have to be 3. So it looks like k is going to have to be odd integers, okay? So let's count by odd numbers. K is 1, 3 times 1 is 3. The next odd number after 3 is 3. 3 times 3 is 9. Next, 5 times 3 is 15. 7 times 3, 21. So that seems to be generating the values where the asymptotes are. Is what I've written an option? Answer choice A. 3 pi times k, 3k pi, is the same as 3 pi k. K is an odd integer. That feels right. And the domain. Notice that the range. The range are going to be the values that y can be. And if you look at these humps, you're going to notice that the bottom humps go down forever, and the highest they can ever be is -3. So that's going to be y has to be less than or equal to -3. And then for the up humps, these are going to go up to infinity, and the lowest that these up humps can ever be is +3. And so this would have to say y is greater than or equal to 3. That's where the graph exists. Answer choice C says that. Y has to be less than or equal to -3, or y can be greater than or equal to 3. Fantastic. Man, I hope that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.